Previously, we looked at how vaccines work and the processes required to monitor safety and efficacy for approval. Throughout this video, we're going to describe the complex steps involved in the distribution of the approved COVID-19 vaccines and talk about what it means for you. Currently, 2 vaccines have been authorized by the FDA and recommended in the US. These include the vaccines created using mRNA technology by Moderna and Pfizer, along with its German partner BioNTech. Vaccines are most practical when they are single-dose, do not require cold storage, and can last a long time once opened and in use. Though this is ideal, it's not always possible to produce vaccines this way. Both the Moderna and Pfizer vaccines require 2 shots, cold storage, and have never before been used in practice outside of clinical trials, so their true long-term effectiveness is unknown. It takes time and calculated logistics to successfully create and launch a vaccine. Multiple sites across the United States are working on production and distribution of these 2 vaccines. Nothing about this pandemic has been predictable, and distribution of supplies has been no exception. mRNA production, raw material production, manufacturing, and packaging occur in different cities in the country. Manufacturing mRNA vaccines requires a cold storage supply chain for their effective distribution because mRNA is very unstable at temperatures above freezing. This proves to be more challenging in some areas as compared to others. The Pfizer vaccine specifically must be stored at -70 to -80 degrees Celsius, which is colder than the average temperature in Antarctica. Because of required temperatures, dry ice is necessary for transporting the vaccine. Dry ice can be very difficult to store and cannot be made in advance as it begins to vaporize as soon as it is formed. That's how cold it has to be. The vaccine can be stored for 15 days if dry ice is intermittently replaced. Storage containers can only be opened twice a day for 3 minutes at a time. When it is time to use the vaccine, vials must be thawed at 2 to 8 degrees Celsius and can be used within the next 5 days. The production of glass vials and syringes is also being ramped up to meet increased demands. These requirements mean that manufacturers and distributors have to be very careful in planning how much vaccine gets shipped when and to where, so that enough doses are available when and where they're needed, without wasting doses because of improper storage or handling. In addition to cold storage requirements discussed earlier, patient scheduling, follow-up, and determining logistics prior to administration are crucial. In areas that lack refrigeration, are remote or difficult to reach, or have few people trained to administer vaccines, coordination and timing is crucial to vaccination efforts. When faced with obstacles, immediate solutions need to be drafted to avoid losing materials. One such example was when healthcare workers on their way to a vaccination site in Grants Pass, Oregon, were stranded in a blizzard. Quick-thinking workers were able to offer vaccinations to other stranded drivers to keep doses from going to waste. When a vaccine requires multiple doses, they are typically produced and distributed together and might not differ much in terms of components or quantity. Appropriate long-term storage of the secondary doses is important, and if clinical infrastructure is lacking or doses need to be sent in separate shipments, it might complicate distribution to the public and reduce vaccine effectiveness. We previously mentioned that the true effectiveness of the COVID vaccines is unknown because they've never been used in the general public before. This is true for any new vaccine that's first being rolled out, not just the COVID vaccines. What we call the effectiveness of a brand new vaccine is actually its efficacy, or its function under ideal trial conditions, how well the vaccine does its job before it hits the market. True effectiveness can only be measured in real-world conditions. This includes how the vaccine is stored, handled, how it might interact with other drugs, long-term duration of immunity, and any other unmeasured indirect effects. We don't exactly know how the clinical trial data for the COVID 2-dose schedules looks like in practice, or how long someone can go without getting their booster shot, or if people just don't get the second dose at all. The main reason recommended dose schedules are established is because people can easily just forget to get the second shot. Everyone is trying to get the COVID vaccine, but as we've already seen, this has been a huge challenge just for the first round of doses, let alone having vaccinated people return for the second dose. The first vaccine dose offers some level of protection. However, the second one is required to achieve the 94 to 95% efficacy. So with all this in mind, what does the plan to distribute the COVID-19 vaccines actually look like? As it stands, Pfizer's vaccine seems to be reaching major metro areas first, since it requires more careful transport and storage, and the Moderna vaccine, which requires less strict storage and handling, is making it out to rural areas more easily in comparison. The original federal distribution strategy, Operation Warp Speed, focuses around ongoing location-based needs assessment, cost-free administration to the public, and centralized dose tracking. In practice, distribution of the vaccines looks very different from state to state. However, federal plans are said to be underway. You must be wondering, when and where can I get the vaccine? And which vaccine will be available for me? Although the Pfizer and Moderna vaccines are similar in many ways and both use mRNA technology, their logistical requirements like dosage and storage differ. Therefore, where you are located might determine the type of vaccine you receive. But don't worry, both have shown very high efficacy. If you have the opportunity to get vaccinated with any approved vaccine, we suggest you take it. Keep in mind that it takes a few weeks to develop immunity even after receiving the vaccine. And while the vaccines are extremely effective, they're not an airtight guarantee that you won't get sick or transmit the virus. While infection rates are high, it's best to continue to take safety precautions such as masking and limiting contact with people outside your household if you can, even after getting vaccinated. As more people get vaccinated, community transmission will start to decrease, and then we can begin to ease off some of these other precautions. To determine which populations should be vaccinated first because of their vulnerability to exposure or their susceptibility to the worst effects of the virus, CDC consults with state, local, and tribal bodies, private clinics, and the Advisory Committee on Immunization Practices. For COVID, priority populations include people 65 years or older, those with certain pre-existing health conditions, and healthcare workers. Based on the CDC recommendations, each state has set up its own prioritization plan. To find out if you are currently eligible to get vaccinated or when you will be, contact your state health department. Vaccination is one of public health's greatest accomplishments, and mass vaccination will help solve our current situation. It will take great efforts and patience, but this will get us one step closer to the end of the pandemic. Until the vaccines create sufficient herd immunity and until evidence indicates that returning to normal activity and commerce is truly safe, we need to maintain the new business as usual of distancing, wearing masks, and sanitizing. It's only a matter of time until the curtains close on this crisis.